Okay, so I'm going to put up on the whiteboard. I'm going to put a couple numbers up. I would like you guys to change that to scientific notation, and then I want you guys to share it with me. So, okay, you guys have some answers for me? Leslie, can you write on my screen? You have annotate. You know how to do that? Okay, so the way that you would do that is if you hit, there'll be like at the very top, it'll say you're viewing Dr. Henry's screen or something like that. So if you click on that and go up, there should be ... or you'll see options. So you want to click on options. And then if you look at options, there should be annotate. Now, if you have a Chromebook, do you have a Chromebook? Okay, if you have a Chromebook, you're not able to do that. At least as far as I know, they haven't updated it so that you can do that. They may have, you can check to see. But for those who don't have Chromebooks, you're able to annotate. So you want to look for that annotate. And then when you click annotate, you'll see text, draw, stamp, spotlight, erase, format, undo, redo, clear, and save. You guys see that? Those who are... You don't see that, or you do? Thumbs up, thumbs down. There's only 5 of us, so we should be able to talk freely. Okay. So if you guys can do me a favor, those who are able to write on the screen, can you just do me a favor and sign your name on the screen? And also, since I have you guys here, are you guys opposed to extra credit points? Yes, no, maybe. God, you guys are so talkative, Leslie, are you opposed to extra credit points? How about you, Paulina? Maria, are you opposed to extra credit points? I know Vernice is not opposed to extra credit points. So currently it is Latino Heritage Month. And on your campus, you guys have a lot of activities that are going on. You guys probably saw the flyers in your emails. So if you guys take a picture of any of the activities that you attend, you will get up to, at maximum, 5 extra credit points. So let's say you attend 5 events. For each event that you get, you'll get an extra credit point added on, and that'll be added on to your test score. Okay. So I'll be putting that up on Canvas. And so there are going to be some Zoom events. There's going to be some face-to-face event. I know that some of you guys are having face-to-face classes. So when you're on campus, take advantage of some of those events, and you guys will get extra credit for it as well, too. Is that cool?
Yeah.
Okay, good. Okay, so we need some answers here. So who's going to help me out? Who's going to volunteer, or do I have to volunteer somebody? I know Leslie is going to help me out with the first one. So Leslie, if I want to put this in scientific notation, what do I need to do? So what is scientific notation? Anybody want to help me out? Okay. Anyone? Ah, there we go. It's when we have to use times 10. Yes. So because we're scientists and we hate writing things out all the time, we try to find the quickest ways of writing things out. So in chemistry, you'll find I'll refer to being lazy a lot because concept of being lazy is the aspect of using the least amount of energy as possible. And so as scientists, we often are like those molecules. We want to try to use the least amount of energy as possible. Okay, so scientific notation is a way of doing that. Rather than always having to write out all of these zeros, we try to find ways to make it shorter so it'll be sweet, simple, and easy to understand. And so there's less likeliness somebody else making a mistake by adding too many zeros or taking away too many zeros. Okay, so let's go through this process together. So if I'm going through scientific notation, I need to figure out to what exponent am I going to be multiplying by, right? So we need something in the simple format of A, C, D times 10 to the whatever power, to the exponent. We'll call this E. Okay, so we want it in this format. And don't tease me too bad about my first grade handwriting. So to get this in this format, if you guys recall, we need to move this decimal. Which way are we going to be moving this decimal to try to get it in this format? Right or left? Okay, so we're going to be moving it to the right. So that's 1, 2, 3, 4, 5, 6. Okay, so that's going to be 6 to the right that we're going to be moving it. So our number is going to be 2.395 times 10 to the 6th power. Okay, so what about the number below? So first off, the decimal is going to be located right after that 0, right? So which way am I going to move the decimal?
To the
right
left.
or left?
Left.
I'm sorry, I cut you off.
To the left.
To the left. Wasn't there a song by Beyonce? To the left, right? So 7.5 times 10 to the, forgot how many there was. 1, 2, 3, 4, 5, 6, 7. Oops. And I forgot to put my negative up here. So when we're moving it to the right, we have to also remember to put the negative. All right. So that also lets us know that negative lets us know that that number is really, really small. It's going to be smaller than 1, much, much smaller than 1. If we move it to, if we move it to the right, it's much, much less smaller than 1. If we move it to the left, we know that that one is going to be much greater than 1, right? And so that one is going to have a positive exponent. Okay, questions? Concerns? Okay, so everybody remember that, right? Oh, by the way, I should let you guys know, this week, I will be opening up your practice tests. So your practice test will be opening up this weekend on Friday. And so your tests will be not this week, but next Friday, I'll be opening up your real test. So you'll have a week essentially to work on your practice test before I open up your real test. Okay? How are you guys doing? Good. Okay, good. Okay, so this is scientific notation. So we also talked about dimensional analysis. We kind of briefly touched on it. We just had started on it. And so I want to talk about that a little bit more. So we'll go back to the lecture and we'll talk about those items for dimensional analysis. Let me pull that up. Now, if we've gone over this, you got to remind me because I'm old you know, and I have like so many classes, and I work on, and I should say work and live on approximately 5 to 6 hours of sleep, you know, so, or not even that, if I'm lucky, 5 to 6 hours of sleep. Last night it was about 3, but let's see. Can you guys see my screen?
Yes.
Okay. So we're going to be talking about equivalencies and conversions because we've kind of touched on it already. And so the thing that you want to know about equivalencies allows us to sit there and make things relatively equal. Like for instance, we often will use equivalencies or what we call conversion factors. Okay, so we were talking about equivalencies. So how many days are there in a year? $365. Excellent. Okay, so we know that there's 365 days in 1 year. So we can say 365 days 1 year. That's my abbreviation for year. Okay, so let's say I have been working and teaching for 6 years. Okay, so if I want to figure out how many days that I've been teaching, can I do that? Yes, no, maybe. Okay, so let's go with that process, how we can do that. So what we do is we do something that's called dimensional analysis. I like to use the grid or a box like type of structure. So I know that I have years and I want to have days. So in this case, at the end of my equation, I want to end up with days. So I want to try to get rid of years. So I know that 1 year is equal to 365 days. So I'm going to put years at the bottom so that my units will cancel out. So do you guys remember in math where we looked at fractions, where we have 2 over 2? What does 2 over 2 equal? 1. Okay. What about x over x? What does that equal?
1.
1. Okay. So if I have x cubed over x cubed, what does that equal? That's right, 1. Okay. So in all of those cases, that equals 1. So that's going to be the same case with units. If we have the same units over the same units, they're going to cancel out. They're going to equal 1. Okay, so we're able to get rid of those units. Okay, so on top, I'm going to put 365 days because I want days. So I want to end up with the units of days. So as I said, my units of years are going to cancel out. So I'll just multiply 6 times 365. And I end up with 2,190 days. So if I was putting this in scientific notation, it would be 2.19 times 10 to the what? 1, 2, 3, 10 to the third. Okay, so my computer's getting ready to crash again. Are you guys still there?
Yes.
Okay, give me a minute. It's getting ready to crash on me again. It's not responding to certain things. So give me a minute. I'll come right back on. So I'll see you guys here in a minute. I apologize for this. Seems like we always have so many technical issues when we try to meet. So I'll be right back. So we know that we can sit there and use time to sit there and change from one unit of time to the other unit of time. Okay. And so that would be an example. But let's say we're doing something like driving and we want to figure out how long it's going to take us to get somewhere, right? So let's say we know that we travel at a certain speed, okay? So, or a velocity. So what is the current speed limit in Salinas? Alberto. So what is the speed limit in Salinas?
Salinas, I'm not sure.
Where are you at?
North Salinas?
You're in North Salinas? So what is the speed limit in North Salinas?
I think it might be like residential. I think it might be 25, but I'm not sure.
Okay, so we'll say it's 25. So we know it's 25 miles per hour, right?
Yeah.
Okay, so that tells us 25 miles per hour. MI is the abbreviation for miles.
Mhm.
Okay, so that tells us in 1 hour, we should be able to drive 25 miles, right? So that would be an equivalency factor. It allows us to sit there and change that distance to time. So let's say we have to travel 40 miles. So if I have to travel 40 miles, how long is it going to take me to get there? If I have to drive 20 miles per hour, 25 miles per hour. Well, in this case, we'll use this equivalency to sit there and determine it, right? In this case, we're going to put the 25 on the bottom. $25 miles. And we want to make sure that we keep those units. And then we put hours on top. So then miles are going to cancel out. And we're left with hours. But let's say we want it in minutes instead of hours. So what is the equivalency for hours to minutes? What is that conversion factor?
So 1 hour equals 60 minutes, huh?
Okay, we know that 1 hour equals 60 minutes. So I can use that equivalency as well here, right? To sit there and put it in terms of minutes. So in this case, I want to end up with minutes. So at the end of the day, I want my answer to be minutes equal over here. And we want to end up with minutes. So I'm going to put 60 minutes over 1 hour. So then in this case, the hours are going to cancel out. And so we would be left with just minutes. So in this situation, we just multiply the top. So you multiply across at the top, and then you divide what's on the bottom. Yeah, 40 times 60 divided by 25. Because when we multiply by 1, we know we get ourselves, right? So we end up with how many minutes? We end up with 96 minutes. Okay, simple. Now you guys see how to use the equivalencies or conversion factors? Okay. Okay, so here's your example. 1 day is 24 hours. Okay, so that would be an example of a conversion factor, right? 1 day, 24 hours, they're both the same units. Okay, so an equivalency would be 17 miles per gallon. So how many different ways can I sit there and write this conversion factor? 1 day, 24 hours and 17 miles per gallon. How many different ways can I write that? Sam? Samantha? Do you mind, is it okay if I call you Sam? Or do you prefer Samantha?
Sam is fine.
Okay. Samantha, can you help me out with this?
Yeah. So there's 24 hours and days, and then
Okay, so I could say 1 day is equal to 24 hours.
yeah.
Or I could write it as a fraction, right?
Mm-hmm.
Okay, so I could put 1 day on top.
24 on the bottom.
"24 hours on the bottom. Or I could put 24 hours on top. And 1 day at the bottom. So that allows me that flexibility. So if I know I want to get to one set of units, I can use either option, right? Okay. Now, can I do the same thing with my average speed of my car down here, that 17 miles per gallon? How could I write that? Sam, are you there? Did I lose you?
Oh, my bad. You could put 1 gallon over 17 miles.
You're so soft-spoken. Are you always soft-spoken, or are you just that way with me?
I think I'm always like this. I don't
Okay.
know.
Okay.
I'm a little tired still, so.
Yeah, I know. The coffee hasn't set in yet. I feel you. I'm right there with you. And then we already had, you know, the disruption with the connection too. So you're like, okay, let me get it back in the mood.
Uh-huh.
Yeah. Okay, so you're saying, got to talk a little bit louder because, you know, I'm getting old, hard of hearing. Can't you see the gray hairs on my hair? You know?
No. Thought you were still young, you know? So I think it's
Flattery will get you so many places, let me tell you.
I think it's 1 gallon over 17 miles.
Okay, so I can go 1 gallon, and you said over 17 miles.
Uh-huh.
Okay. What else can I do?
Or 17 miles over 1 gallon.
17 miles over 1 gallon. Okay. Now the key is that we want to make sure that we keep the units together. 17 miles needs to stay with, I mean, the 17 needs to stay with the miles, and the 1 needs to stay with the gallons. We don't want to mix those up because then that'll just throw everything off, right? I know, I'm just telling you guys stuff that you already know, but I want to reinforce it. Okay, good. So let's move on. Okay, so if you need a step-by-step of how you need to go about doing this, this is called an algorithm. An algorithm is basically writing out a step-by-step means of doing it. I like to always start, and I like to say, I always start with my given. That always means that I'm going to include my units and everything when I do my given, because units are important. Did we talk about, my computer wants to restart again. Let me see. Let's see if I can do it for me. Okay, so we're going to make him kick us off this time. So if we start with our given, right? And usually that's going to be 1 type of unit. We're given a 1 type of unit, and we're going to use our equivalencies to sit there and fit to what we want. Okay. So did I talk to you guys about Tinder and swiping last time? No? Okay. How many of you guys know what Tinder is? Yes. Sam says, yes, we talked about it. Or are you saying, yes, you know what Tinder is?
Both.
Both. Okay. So just a reminder, I'll give you guys a quick reminder. So if I said in my Tinder profile, Tinder is, for those who don't know, it is a dating app, right? And so you swipe left if you want somebody and you swipe right if you don't, something like that. I can't remember which direction you swipe. So you can't tell my girlfriend though. I have a Tinder profile.
Yeah.
Okay. So on my Tinder profile, I say I weigh 100. Now, if you were a person that was looking for somebody, if somebody told you that they weighed 100, what are you going to think? Alberto, you're very vocal. What would you think if somebody told you they weighed 100 and they're a guy? I guess I lost him. Bernice, what would you say? What would you think? Now, again, you're just reading the profile and everything like that. Are you there, Bernice? You wouldn't think anything? You'd be okay, that's cool. You would say he's fine? If he said he weighed 100, 5'9", 100 pounds? So you like your man really, really skinny, huh? Okay, so you'd be like, oh yeah, I'm definitely keeping him, huh? So really, really skinny. So you'd be okay with that, okay? To each his own, everybody has their own little, thing. What about you, Paulina? What would you say? Somebody said they weighed 100. Are you there, Paulina?
Yeah.
Yeah? What would you say? 100?
I would think that they have like something wrong with them, or like they don't eat.
Yeah, I would think that they wouldn't eat. I mean, they're 5'9" and they weigh 100 pounds. That's pretty skinny. That's like skin and bones. Okay, so my first instinct would be, we're talking about 100 pounds because they didn't say the units, right? So since there are no units there, we can't sit there and figure out what they're talking about, right? So we're going to make assumptions, okay? But if they said they weighed 100 kilograms, and if we knew that the conversion for 100 kilograms, or the conversion for a kilogram is 1 kilogram is equal to 2.2 pounds. So if we did that dimensional analysis, we'd know that this person actually weighs how many pounds? Anyone? That's right, 220 pounds. Okay, so then you'd be like, okay, so he's 220 pounds, he's 5'8". Oh, he's thick bone, thick and sexy, right? So you'd be like, oh yeah, I'm keeping him. Okay, so you guys see the importance of using units? So if we don't know the units, then we're trying to figure things out, right? So that's like the same thing. If I said, you guys need to be here in 5. Is that 5 days? Is that 5 minutes? Is that 5 hours? Is that 5 years? You just know 5. You don't know what it is, right? So you would need more clarity. And so we use those units for clarity. And so it's important to always include units. Are you guys with me?
Yeah.
Yep.
Okay. Now remember, I hate talking to black screens in the first place. So you guys have to make sure that you guys are responding. Give me thumbs up or, yeah, or something every once in a while. Make sure that you guys are still alive. Okay, so like I said, this is the algorithm, and you guys can read that on the screen, so you don't need me to sit there and take you through it, but we can take you through it with an example. Okay, so let's go ahead and take it through it with an example. Okay, so calculate the number of weeks in 672 hours. Okay, so what's my given?
$672.
672. And those units? Hours, right? Because we want to make sure that we put hours, because we know it's not 672 days, right? Okay, so what are some of the equivalencies or conversion factors that we know about hours? We want to end up with weeks. Our goal is to end up with weeks.
What about days?
Okay, so what about days? Okay, so how many hours are in a day?
24.
Okay, so there's 24 hours in a day. I'm going to write that up here. Right. Okay, so we have 24 hours in a day. So in this case, we can get rid of hours and get days. So we put 24 down here. One day up top. Okay, hours cancel out. Then what we're going to be left with is days, but we want weeks, right? So if we want weeks, how do I convert days into weeks? So we know that there are 7 days in a week. That's right. So am I going to put days on the bottom, or am I going to put days on top here? If I want to get rid of days, right now we have days on top.
On the bottom?
On the bottom. So we're going to put 7 days on bottom. And 1 week on top. So then, because they're catty corner, one on top, one on bottom, they're going to be able to cancel out. Okay, so then when we do this multiplication, now we're left with just weeks. Okay, so we multiply across 672 times 1 times 1, that's 672, and then we divide by what's on bottom. Okay, so we end up with what? 4 weeks. Good job. Okay. Questions, concerns, Cash? Okay. Okay. So what distance expressed in miles will an automobile travel in 3 hours at an average speed of 62 miles per hour? So what distance expressed in miles will an automobile travel in 3 hours at an average speed of 62 miles per hour? So how would I set this guy up?
Would it be 62 times 3?
62 times 3? Yeah, it essentially be 62 times 3. But what I would recommend you do is get in the habit of making it a routine. Start off with what's given. So we start off with those 3 hours. That's our given. And then we know that we're going to be multiplying it by 62 because it's 62 per 1 hour. So we have 62 miles over 1 hour. Now, the reason I say this is because problems are going to get a little more complicated than something like this, right? And keeping track of those units are going to be important, particularly in chemistry. So we just have 3 times 62. What do you guys end up with? $186 miles. Okay. Simple, not too hard, right? Good job, Sam. And did I say your name, Aldoberto? Is that right? Or did I mess that up?
Yeah, Alberto. Or you can call me Beto for sure.
Berto for short. Okay.
Yeah.
Whatever you want me to call you, you know. I promise I will probably butcher it for the first, most of the semester, but I will work really hard to try to get it right.
No, that's fine.
So I'll call you Berto if you want me to call you Berto, but if you want me to call you Aldoberto, I'll work on it.
All right. Yeah, you can call me. Yeah, Beto.
Okay. Okay. So a little girl broke her piggy bank. Inside, she found 2,608 pennies. How many dollars does she have? So how would I set this guy up? What's my given?
The 2,608.
And the units? Pennies, right? Don't want to forget those units, right? Otherwise, we're going to be getting rid of a hot guy that weighs 100 kilograms. Okay. So then how do I convert that to dollars? What do we know about a dollar and pennies?
100 pennies.
100 pennies.
Equals dollars.
So we know that $1 equals 100 pennies. So we end up with 26.08 cash money. Okay, simple, not too hard, right? Okay, so let's see. Let's see if we can make it a little more challenging. Okay, so let me introduce you guys to the metric system. Are you guys familiar with the metric system? Good, good. So this should be pretty standard. Okay, so the metric system is basically a unit of measurement that is based upon factors of 10. We will be talking about it because in scientific purposes, it is a unit that we like to use because it's a lot easier to use. It's basically used worldwide, except, in the US for our normal things, we don't use it because we like that imperial system. I don't know why. We just get stuck in ruts, and so we stick with it forever. And so as I said, the beauty of it is that it is based upon factors of 10, decimal based. Okay, so let's start talking about it. The other thing that I want to say about it is that it's also used what we call SI units. SI stands for the International System of Units. And it's basically the standard that, as I said, we use mostly in science, okay? So the metric system is going to be defined by what we call these prefixes. So we'll have our base unit, right? So like grams would be a base unit, or liters would be a base unit, or even times, seconds would be a base unit. Okay, and so we use prefix to sit there and determine whether a number is going to be a large unit or whether it's going to be a small unit. And so I'm going to kind of introduce you to some of the prefixes, and you guys need to know these because you're going to see them consistently, particularly if you're going to go into areas of nursing and things to that extent. Okay, so for example, we have the unit, the prefix kilo, right? So like a kilogram, we just talked about a kilogram, right? So a gram, 1 gram, is equal to 10 to the minus 3 kilograms. Or we could say 1,000 grams equals 1 kilogram. Okay, so that kilo basically means 1,000 times our base unit. Does that make sense? Okay, so both of these equivalencies are true. Okay, so mil. What does mil mean in Spanish? How many of you guys speak Spanish? Anybody speak Spanish? There are no Spanish speakers? Okay, mil. Mil means what? 1,000. Okay, so millimeter, that would be 1,000 millimeters. Mil. Will equal 1 meter. Or we could say the abbreviation for millimeters is mm. So 1 millimeter equals 10 to the minus 3 meters. The abbreviation for meters is in. Okay. Okay, makes sense. Easy way to remember what a millimeter is to a meter, right? Or that prefix mil, a milligram to a gram. Okay. Are you there? You guys are good? Can I move forward? Good. Okay, so these are our prefixes. So these are our large units. So our base units, like I said, will be grams, meters, liters, or some unit of time, seconds. So this represents 1 gram. So we know that a deca means that that would be 10 times greater than the gram. Hecto would be 100 times greater. Kilo is going to be 1,000 times greater. Mega is going to be 1,000,000 times greater. Giga is going to be million, so then it would be billion times greater. And then tera would be 1,000,000,000 times greater. Okay. Now, on our small units, our base unit is here. So this is grams. So then deci would be 0.1 times smaller, or we could say 10 times smaller than. So like a decade, 10 times smaller than a gram. Okay. Centi, like a century, would be 100 times smaller than a gram. Milli would be 1,000 times smaller than a gram. Micro would be 1,000,000 times smaller than a gram, 10 to the minus 6. Okay. Nano would be a billion times smaller than a gram, or 10 to the minus 9. And pico would be 10 to the minus 12, smaller. Okay. So 1 picogram would equal 10 to the minus 12 grams. Okay. So let's see if you guys can test this out. Okay, so I have 250 grams. How many milligrams is that? So the abbreviation for milligrams would be mg. So how would I go from 250 grams to milligrams? What would be the equivalency or the conversion factor in this case? Mil means what again? Thousand. So we know that 1 gram is equal to 1,000 milligrams. So that would be my conversion factor. Okay, so then if I have 250 grams, so that would be my given. So 250 grams I want to get rid of grams. So what am I going to put on top and what am I going to put on bottom? What goes on top? 1,000. 1,000 milligrams is going to go on top. And 1 gram is going to go on the bottom. So grams are going to cancel out. And we're going to be left with milligrams. So then we just basically multiply 250 times 1,000. So that's 2, 5, 0, 0, 0, 0 milligrams. Okay. Now let's say I wanted to convert this into kilograms, or let's say hectograms. So 250 grams, but I want to change it to hectograms. So how many grams are in a hectogram? One hectogram equals H grams. So hecto would be H grams. Would equal how many grams based upon this? 100? That's right. 100 grams. Okay, so then to do that conversion, we do 250. I want to get rid of grams, so who's going to be on top and who's going to be on bottom? That's right, 100 is going to be on the bottom. So those 100 grams are going to be on the bottom. And then we have 1 hectogram, HG. So then we get 2.5 HG. You see how that works? So you want to be comfortable with using these units and those conversions, okay? That's going to be crucial. It's going to be really important, okay? Because you guys are going to see this throughout the rest of the semester, okay? And we're often going to be working with grams, milligrams, moles, which we haven't talked about yet. We will be talking about millimoles, liters, milliliters, okay? So you want to be able to can go from mil, definitely mil, centi, kilo. Those are the ones we use a lot, and micro when you're in the nursing area. Okay. Okay. So let's talk about mass and weight. Okay. So what is the difference between mass and weight? So if I was on the moon, would I weigh the same amount that I do on Earth? No.
No.
Okay. Why? Why would I weigh differently? That's right. So Sam says because of gravity. So weight is dependent on gravity, where mass is not. Mass means that you're going to be weighing the same on both, well, not weighing. Your mass is going to be the same on both the Earth and the moon, but your weight is going to change because weight is dependent on gravity. Okay, and so we want to keep that in mind. Just, kind of keep it in mind as one of those things that always crops up on an exam or something like that. So, okay. So when we talk about it, we often will be using mass. And so when we make reference to mass, we're going to be using kilograms. Kilograms are the units for mass, particularly when we're talking about somebody's weight or what we would use, right? Because I talked to you about earlier about I weigh so many kilograms, right? So in science, we'll be using kilograms, we'll be using grams, and we'll be using milligrams, depending on what we're using, right? So if we're talking about somebody's weight, we're going to be using kilograms. If we're talking about the weight of, let's say, a chemical that we're going to be using in solution, we may be using grams if we're going to be using enough of it, or we may be using milligrams if we're using very, very, very little of it. Okay. So we want to be aware of the units that we're using. The normal SI units, though, is kilograms, but we use that conversion between grams, kilograms, and milligrams often. So that's the same thing with distance. The unit that we use for distance is going to be meters. The abbreviation for meters is M. The abbreviation for grams is G. Kilograms is kg. Milligrams would be mg. Nanograms would be ng. Micrograms would be mu-g. This is what a mu looks like, G, or micrograms. Okay, so when we talk about meters, as I said, the abbreviation for meters is M. So a kilometer would be 1,000 times more than 1 meter. Okay, so it's been determined that the length of the path traveled by light in a vacuum is 1 divided by, and it's really 3.00 times 10 to the minus 8 seconds. So in other words, we can say 3 times 10 to the 10 to the 8th meters per second. is the speed of light, okay? And so the meter was kind of derived based upon that speed of light, based being that unit of time, okay? So when we're talking about longer lengths, we're going to be using the kilometer. When we're talking about those shorter lengths, we're going to be using centimeters or millimeters. Okay, so often we have units like we use certain things that are defined to keep track of what things weigh or lengths of things. And so like in France, there's a vault of platinum and iridium cylinders that are used to sit there and calibrate scales. And so it's based upon a kilogram. So a kilogram weighs 2.2 pounds. And so we have a mass that is a kilogram that is going to be used to basically balance the scale. And so this is basically that unit that we keep in storage to sit there and make sure that we keep that unit right and it maintains that same unit, okay? And so there'll be, you can actually buy from this particular company weights that will actually be used for that, or you can get them basically from any distribution company in the world now. But initially, this is what was used to sit there and define that unit of mass. Okay, so we also know that 1 inch is going to be defined as 2.54 centimeters. So 1 inch is going to equal 2.54 centimeters. So we're able to convert our units, which we use basically inches, feet, yards, into centimeters. So we can go from the imperial system or the US system to the metric system. And so we need to be able to go between that. Again, we use pounds, and then they use, most of the world, or in science, we use kilograms or grams. So when we talk about volumes, so often we will use, for volume, we'll be using gallons. We'll be using, what are some other units for volume that we use in the US? Volume. Anyone? Anybody drink soda or water?
Yes.
Yes. So what are some of the units that you guys see on those bottles of water that you drink? Or soda? Liters, fluid ounces. Okay. What about when you go have a beer? Anybody drink beer? What do you order? Fluid ounces. Do you say, I want a fluid ounce of beer? Or when you're in the kitchen?
A
Anybody
gallon?
cook?
Mhm.
A gallon of beer? That is a lot of beer, but maybe a pint? We'll have a pint of beer. That's right. Okay. So so often we'll have a pint of beer, right? What do you guys, and in the kitchen, you guys, we use pints, we use what else for volume? Milliliters. Recipes often call for what? Tablespoons. I like that one. Yeah, tablespoons, teaspoons, cups. That's right. So we often will be using various units for volume to represent volume. What is volume, by the way? Anybody? Okay, so I'll share with you what I believe volume is, and you guys tell me what you think. So volume basically is going to be representing the space that's being occupied. So often when we talk about volume, we'll use something like cubic centimeters, or we will say milliliters or liters, right? And that's going to represent space, right? So we talk about cubic centimeters, that's usually the length times the width times the height of something. Isn't that the space being occupied? Yeah, no, maybe. Okay. Okay, so often volume is going to be represents that space that's being occupied. So how many of you guys watch those doctor shows like Grey's Anatomy or I don't know, can't think of any of them right now off the top of my head. Grey's Anatomy, because that's the only one I can remember. Chicago Med, thank you. Okay, you guys watch those shows? And the doctor says, I need 5 cc's stat, right? What is 5 cc's? We know what stat means. That means right now. It's a unit. What type of unit? What does that mean? cc's. It's a volume. That is right. It is a volume. But what does it mean specifically? We're getting there. We're going to get there, Bertha. cc's. Take a look at the screen. cc's. What do you think cc is abbreviation? Exactly, cubic centimeters, right? So cc's just stand for cubic centimeters. So we know that often we will make reference to cubic centimeters, particularly in medicine, right? So we'll use that term cc's for cubic centimeters, okay? Which still means the same thing as centimeters cubed, same thing. So 1 cc, if you guys ever look on a syringe, it'll say cc's on one side, and a lot of times it'll say milliliters on the other side. So 1 cc's or 1 cubic centimeter is going to equal to 1 milliliter. So we also know the abbreviation for cubic centimeters in the US are cc's. Okay? Okay, so if I know that 1 cc is equal to 1 milliliter, and let's assume that I have 371 liters, which is a whole bunch of liters. How many cubic centimeters would that be? How could I change those liters into cubic centimeters? What are my equivalencies that I can use? How many milliliters are in a liter? So if I want to get to cubic centimeters, that's my goal. Or cc's from 371 liters. Oops, didn't mean to do that. How many milliliters are in a liter? Anyone? 1,000. That's right. So we know that there's 1,000 milliliters. In 1 liter. So liters are going to cancel out, and we're going to be left with milliliters. What is the conversion factor for milliliters to cc's? And don't all you guys yell at me at once. Bernice, I know you know. Come on, help me out there. how many milliliters will equal, there we go, 1 to 1. That's right. So we know 1 cc equals 1 milliliter. So milliliters are going to cancel out, and we're left with cc's. So times 10 to the 5. All right. Okay, questions, concerns, Cash, Kool-Aid? Okay. Good. Haven't run out of time. Good still. Okay, so here we have the conversion factor. We know that 1 milliliter equals 1 cc, or we could say that 0.001 liters is going to equal to a cubic centimeter. Okay, and this kind of helps us realize the distinction between that distance, those millimeters, and those cubic centimeters. Okay, the relationship. Okay, so at the end of the day, we can sit there and use the relationship between our prefixes to help us determine those conversion factors. Okay, and so this just basically kind of defines that in a very generic form. So here we're saying units, so it can be any type of units that we're talking about. So we have 1,000 of any units, or 1,000 of grams, or 1,000 of meters, or 1,000 of any base unit that we have, liters. So 1,000 of units per kilo unit. Okay, and so that allows us to do those conversions, and we can use it in any the forms. We can put it on top or on the bottom. Okay, that's the same thing with the centi. We know that 100 centi units will equal that unit. We know that 1,000 of any milli-unit will equal that unit. Okay, and then we can use those conversion factors. Okay, so knowing that, how many grams are in 0.711 kilograms? So what would I do? What is my given? So what is the given here? That's right, 0.711 kilograms. Okay, so how do I convert this into grams? How many grams are in 1 kilogram? So 1 kilogram equals how many grams? Not 100. Up one more. 1,000. That's right. So 1,000 grams equal 1 kilogram. So if I have that conversion factor, how can I use it? Who's going to go on top? Who's going to go on bottom?
On top, it's the 1,000 gram, and then on the bottom is the kilo.
Okay. So it's the one that we want to end up with. So that's going to be that 1,000 grams. And then you said on the bottom, we're going to have that 1 kilogram. That's correct. Okay. So we end up with Okay, 1, 2, 3. So 711 grams. Okay, piece of cake. Okay, good. Okay, so now if we're converting from 5.25 times 10 to the 5th milligrams to kilograms, how do I go about doing that? What's my given? So here we know that my given is, yes, those milligrams. That's right. So that 5.5 times 10 to the 5th milligrams is going to be my given. So that's what I'm going to start off with. Times 10 to the 5th. mg for milligrams. Okay, and I know I want to get to kilograms. I'm going to put equal kilograms. That's my goal, kg. Okay, so I know that a milligram, a mil equal how many grams? A milligram equals how many grams? Or I'm sorry, a gram equals how many milligrams? Should be what I ask. 1 gram is going to equal how many milligrams? Mil? Anybody? 1,000? 1,000 milligrams. Okay, so put 1,000 on the bottom. Those units are going to cancel out. And 1 gram on top. Okay, we talked about that earlier. Kilo means what again? So how many grams equal a kilogram? 1 kilogram equals how many grams? Somebody said it earlier, 1,000. So then we know that 1 kilogram on top, and we have 1,000 grams on the bottom. So then grams cancel out, and we're left with just kilograms. So at the bottom, that'll be 10 to the 6th. On the top, we have 5.25 times 10 to the 5th. So my answer is going to be 0.525 kilograms. Or we could write it as 5.25 times 10 to the -1 kilograms. Okay, question, concerns, cash, Kool-Aid? No questions? So I have a question. Has everybody got their kit? Yes? Did you get the supplies? Did everybody get the supplies? Yes? Okay, so you want to make sure you guys have that by Friday, because that's going to be your very first lab. I want to start falling behind and everything, because you guys have been on top of things compared to some other students. So we want to make sure that we stay on top. So the very first experiment that we're going to be doing is the Mentos experiment. I'll be putting up the instructions probably on Thursday, so you guys can take a look at it before we do it on Friday. And hopefully you guys are there. If not, make sure you guys watch the video. That's so weird, watch my video. I feel like a YouTube personality or something. Yeah. Okay. So I will be talking to you guys about it again by email, so you guys will be well informed. Okay, so let's move on. Let's keep going forward. Sorry, I get hungry after a while too. My brain I have to keep feeding my brain and my belly. You know, I don't want to get down to 100, you know. Okay, so let me clear this. It says a fruit drink is sold in bottles that contains 1,892 milliliters. Express the volume in cubic centimeters and in liters. So how would I go about doing that? What's my given? That's right. 1,892 milliliters. And we're changing from milliliters into cubic centimeters. So how would I do that? What is the conversion? That's right. We know that 1 cc is equal to 1 milliliter. So this one's easy. 1,892. Oops. cc's. Okay, so what about liters? If I want to change it to liters, our given is the same. So 1 liter equals how many milliliters? Thousand, that's right. So 1 liter, 1,000 milliliters. So those units cancel out, and we're left with 1.892 liters. Okay. Questions, concerns, cash, Venmo? Okay. Let's keep moving forward then. Okay. So we're going to be talking about significant figures. So when we talk about measurements, we often have to be concerned with how accurate our measurements are, or how uncertain we are about our measurements, right? So I'm not familiar with Hartnell's lab and anything like that, but I can tell you about the West Hills lab. In our labs, we have these really, really old scales, right? And some of them, we have analytical scales, and some of them, what we have, they're called deci scales. Deci scales basically only goes to the 10th spot, so it goes one past the decimal. The analytical scales are more accurate. They go like 3 spots beyond the decimal. So a deci scale will be something like this. So we weigh something and it'll weigh, let's see if I can get it. It'll be like 5.1. Where an analytical scale, say grams, where an analytical scale is going to give us 15.0753 grams. Okay. So which scale, if this is the A is the deci scale, decigram scale. And B is the analytical scale. Okay. So which scale is going to be more accurate? Brittany, are you there? Or Gabby? It's okay if I call you Gabby?
Yes, that's fine.
So which one's going to be more accurate, A or B?
B.
B is going to be more accurate, right? So we're going to have uncertainty about the values that are beyond, in the case of A, beyond that 0.1, right? So that 0.1 could be, it could be 0.1, or it could be that 0.753. We don't know because we have uncertainty associated with that. Okay, so that's what I mean by uncertainty, right? So one scale allows me to be accurate, one allows me to be less accurate. So we have uncertainty associated with those values, right? And so let's say you use both of these to sit there and do the measurement, right? So we know that there's uncertainty associated with this value. So we don't know about these numbers here. We're not 100% sure about them because we have this one that only goes up so far. So a lot of times, or what we've done before is we would put plus or minus values here. So we put plus or minus whatever we think that uncertainty value would be, right? So it'll be plus or minus 1 or something to that extent here. Where here, this guy gives us a little more accuracy. We know that these values may be good, but we know that down here to that third, that last one, there might be some uncertainty associated with that. It might really be a 3, or it could be 297 or something like that beyond there. Does that make sense? Okay, so if we're taking measurements, we have to take in consideration that uncertainty. And sig figs allows us to do that. So I'm going to show you how to do sig figs. We're going to kind of take it off the screen for a minute on a whiteboard. And then we're going to come back, and then we'll come back to the lecture. Okay. So let's get to a whiteboard. Can you guys see my whiteboard? Okay. So when I talk about sig figs stands for significant figures. I just like using the abbreviation because, again, a little lazy. What's going on here? Okay, so we're going to be talking about significant figures. Okay, so when we talk about significant figures, we're going to be looking at zeros and where they're at and where they're located at to mainly tell us whether or not a number is going to be significant or not. So if we have zeros in between two whole numbers, like in this case are two numbers, two non-zero numbers, such as 203, this zero is significant. So if we say, how many significant figures does this have? We would say, this guy has how many sig figs then? How many figures are there? How many figures? We have 2, 0, and 3. How many figures is that? 3. So we would say this guy has 3 sig figs because this zero is called what we call a trapped zero or a captured zero because it's trapped between two numbers. Okay. So let's say I have 2, 3, 0, 0. Now, because I don't have a decimal here, right? By me putting a decimal point here, that means that I'm sure about that 0. But since I don't have a decimal point here, I'm not sure about this 0, and I'm not sure about that 0. So the things that I'm sure about, or the ones that are significant in this case, are just the non-zero numbers. So this guy would have 2 sig figs. So these guys are called trailing zeros. Okay. So in this case, only the non-zero numbers are going to be significant. Now, if I have a number like this, now I have that decimal there. So now these trailing zeros, these zeros here, are going to be significant. That in a different color, so it doesn't look like it's part of the thing. So now these trailing zeros become significant because they're behind that decimal and they're behind those non-digit numbers. Okay, so in this case, I have 4 significant figures. So it'll be those trailing zeros in this case and those non-zero numbers. Okay, now these zeros serve as placeholders. They're just holding the spot to let us know that this is a really, really small number, right? So these zeros are not significant. So these zeros up front will not be significant. So, and those zeros are called leading zeros. Okay. So trailing zeros, in this case, if there's no decimal here, those zeros aren't significant. But if there's a decimal, these zeros become significant. Okay. So let me give you another example. Let's say we have this number. Okay, how many sig figs would this be? Somebody said 4. Think about it. If we have a decimal here. And the way I like looking at the decimal is, remember I told you that I'm lazy, right? If I put a decimal here and I write these extra zeros, that's more work. That's right, it's 6. So we have 6 significant figures here. So that's 1, 2, 3, 4, 5, 6. I took the time to put that decimal there. So that means that you're going to count these zeros that are trailing in this case, because I don't have to write them. I wouldn't have to write these zeros. They're not placeholders or anything like that. They're just extra. So I took that extra time. And so as a result of that, I have 6 sig figs. Okay, do you guys get it? You see how it works? No questions? Okay, good. So let's see. I'm gonna ask you guys a couple of questions. And then what I'm gonna do is put you guys in groups, 2 groups, for you guys to discuss it with each other. And then you guys are gonna come back and discuss it with me, okay? So here are your numbers. Okay, that's what you guys are gonna be doing. So take a screenshot of it. I'm gonna throw you guys in a room. Everybody got their screenshot? Now, when you guys get in the room, somebody take charge, be leaders, okay? I'm gonna come in there and check on you guys, okay? Are you guys ready? Okay, good. Okay, so Sam, help me out with the very first one. How many sig figs do I have for that first one?
2.
2 sig figs. Okay. What about the next one? Berto. How many sig figs do we have? That's right, 4. That is correct. Brittany, what about this, the next one?
Five. Oh, sorry. 5.
So we're talking about this one here. So we have how many numbers are going to be significant in this case? Because we put that decimal there, it's going to be a total of 4, right?
4.
That's right. Okay, Maria, the next one. That's right, 4. All right, only these last 4 digits. Okay, and the last one, anybody? Okay, 6. Okay, piece of cake, not too hard. Any questions on this? We end up losing like 4 people along the way, so I don't know if that's because they had questions or what. Okay. Okay, so let's move on. So let's talk about how to determine significant figures when we have addition. So when we're adding things together, we have to pay attention to each of the different numbers and where their significant lies. Okay, so let's say we're adding these 3 numbers together. Okay, so the way that we would determine their significance is by looking at each number independently. So we're going to draw a line between the number that's significant and the number that is no longer, that doesn't have any significance. Okay, so like this very first number, we have 8000. So which is the significant figure? Or I should say, where does significance starts? Is it after the 0? Is it after this 0? Is it after this 0? Or is it between this 0 and this 8? Are these zeros significant? Between the 8 and the 0. Okay, so I'm going to draw a line here. Okay, now this next number, the number is significant after where? Is it between this 0 and 1? Is it between this 0 and 1? The first 0 or the second 0? Well, it's going to be this 0 here, okay? So this last 0 isn't significant, but this is a captured 0, so it does have significance, okay? Now, in the last case, everything is going to be significant, so we're going to draw a line here. Okay, so what you're going to do is you're going to take the line that is the furthest to the left, and that's going to determine that line of significance. So if we go the furthest to the left, that's going to be, I'm just going to say this is A, B, and C, just in case somebody's colorblind. So the red line, which is A, is going to be the line that we're going to be using for significance. Okay, so we're going to erase these others. And then we're going to add up the value. Okay, so we have 0.015 163. Okay, so then we take this number here the one I circled in red. All right. Now, if this number is 5, if it's greater than 5, or it's 5 and there's other numbers trailing it, then we're going to round up. If it's less than 5, or there are no numbers trailing it, it's 5 and there's no more numbers trailing it, we're going to leave this number alone. Okay, so in this case, we're going to round the 1 up. So now our answer is going to be 3, 6, 2, 0, 0, 0. Now, we don't want to put the decimal point, because if we put the decimal point, that means that these zeros are significant, and they're not in this case. Okay, so our answer is going to be 362,000 is going to be our answer. It's not going to be 362 because we need to make sure that we have those placeholders. Okay, are you guys with me? Yes, no, maybe, a little confusing. Okay, so let's see if we can kind of get a little more clarity. Okay, so I'm going to try another number. So this time, let's make it a small number. Yeah, we're going to try to get you unconfused, Maria. Okay, so if we're adding these two numbers, or these three numbers together, what we're going to do is we're going to draw lines where we have significant figures. So in this case, it's going to be after the 0 because we have this decimal here. So these trailing zeros are going to be significant. Okay, in this case, in the second number, it's going to be after that 0. And then the last number, it's going to be after the 5, so which is the same as the orange. Okay, so then what we do is, again, we take the one that is the most to the left, right? The line that is most to the left, and we use the number that's afterwards. This number here is going to be used to determine whether we're going to be rounding up or we're going to be leaving it alone. Okay, so let me erase these guys. So the number on the right-hand side of the line, of the green line, is going to be the one that we determine whether we round up. So we're going to go ahead and add it. So that's 5, that's 5, that's 4, that's 1, that's 0.0. Okay, so we now look at this number that I'm circling in pink. That number, if this number here is greater than 5, or it's 5 with numbers following it, we round up. Okay. If it's less than 5, or it's 5 exactly, with no numbers, we leave it alone. So we'll either round this number up or we'll leave this number alone, okay? Okay, so this guy is 5 exactly. So then my answer is going to be 0.0145. Okay, so we use this number here, right? So after we draw the line, we use the number that is going to be on the right-hand side of the line to determine whether we're going to round this number that's underlined up or we're going to leave it alone. Okay, so if it's greater than 5, we round up. If this number is equal to 5 and there's numbers behind here, then like in this first case, this guy was equal to 5 and there's a 1 afterwards. So we round that one up. Okay. If it's less than 5, if this number is less than 5 in pink, in the pink circle, then we're going to leave this number alone. And then we just drop that 0. It's not going to be significant. Okay. Is that a little bit better, Maria? Can you see it now? Okay. Anyone else? Everybody else is doing okay? So do you guys feel your head is going to explode yet? Okay. Well, I have one more thing, and then what we'll do is stop. Now, the thing is that this is going to apply for addition and subtraction. So the same concept that we're doing here, we're also going to be doing for subtraction. And I'll show you guys how to do that the next time that we meet. But I want to show you multiplication and division, or just multiplication right now, and then I'll show you division when we meet the next time. Okay, so when we do multiplication, okay, so let's say we're multiplying 0.200 times 10.0 times 3.0000. Okay, so in this case, you're going to find the one number that has the least significance. So which one would have the least amount of significance? Let me change this, make it a little more clear. So we'll make that just. Okay, so if we looked at these three numbers, which one would have the least amount of significance? The first number, 0.20, or the least number of significant figures. 0.20, 10.0, 3.000. Okay, and it has how many numbers are significant? That's correct. So we've identified the 0 point. This guy has the least number of significant. How many significant figures does it have? It has 2. So our answer is going to have 2 significant figures. Okay, so if we multiply this across, we'd have 0.6 times 10. So then that would be 6.0. And that's going to be my answer with only 2 significant figures. Simple. Okay. Okay, so let's try an example. So let's do 0.01 times 302 times 1.0000 times 2.0. Okay. Let's talk about the number of significant figures. Which one has the least number of significant figures? Okay, that's right. This guy has the least number of significant figures. How many sig figs does it have? One. It has one sig fig. So that means our answer is only going to have one sig fig. So if we go ahead and do the multiplication, we end up with, so it's 6.04, right? So if we have one sig fig, the answer should be what? 6. That's correct. Okay, that's it. Piece of cake. Okay, so I'm actually going to stop here, and we'll pick this back up next Tuesday. But I'll see you guys hopefully on Thursday. If not, make sure that you guys record your videos so that I can watch you guys do it. So then I will get a chance to see you guys. Okay, so you guys have a good week. If there are any questions, I'm open to questions.
Yeah, I have a question. So, is there gonna be a guide for the lab, like
Yes.
for those who don't? Okay.
Yes, they're going to be instructions for the lab. Yes,
Okay.
and that's going to be
Alright.
posted on Canvas. It's not up yet. It'll be up on Thursday.
All right. Thanks.
And in addition to that, I will also have a recording of me and us doing it. So, okay.
Okay. All right. Sounds good. Thanks.
I mean, not Thursday, on Friday. Yes, that's right. So the lab is on Friday. Did I say Thursday? I meant Friday. So, but the instructions will be posted on Thursday. Okay. I will see you guys on Friday, hopefully. Have a good day.
Bye. Thank
All right. You too. Bye.